Okay, this is an older D1 Mini ESP8266. This is the Pro version, but the regular versions would work the same. And I've had this for a few years. Just started playing around with them again because of the ease of the software available now. And I have this hooked up with just 3 wires to this LED board, which is you can see on there 2812. They're LEDs 2812, and only have 3 wires connected: the ground, data in, and the 4 to 7 volt. And I have them plugged into the board here. I don't know if you can read that. 5 volt goes to the voltage, ground, and I'm using D4 there for the data. And I'm going to show the software. They're incredibly easy to use. So I've just been experimenting around now. Okay, I'm going to show software here that I'm using with the ESP8266. It's flashed with Tasmota, and I showed the LEDs that I have on there, and to set them up was really easy. After you flash the Tasmota, you go to configuration, configure module, and I selected the generic 18 pin, which is what made it into for this D1 mini board. You can see there's a lot of different selections here for different devices. I just picked the generic 18, and then here's the pins, and all I had to do was to select the D4, which I showed the pin. I selected the WS2812, which was the LEDs I had, and then as soon as I did that, you save it. I already have it saved, and go back to the main menu, and this all fills in this color spectrum, so you can change, you can turn it on and off, and you can change the brightness level of the LEDs, and you can change the colors. Actually, this changes the brightness level. This changes the hue. I guess you'd call it the hue, like lighter green, darker green. So that's why these are really fun to use. They're really easy to play with. Okay, I just showed the software. I'm going to show what it's doing, how it's responding. I can turn it on and off with the toggle switch on that software. And then here's the brightness level. You can change the brightness. And here's where I changed the hue from dark green to like a lighter green. You can see it changing somewhat. And then change the color. Go from a kind of a dark red to yellow. Here's yellow. And then getting on greenish green. And just changing this with the slider on the software. Blue. Going over to something more purple. The other end is dark red again. And here's changing the saturation. It's hard to show up on the camera here, but that's all you have to do, and then it can toggle it on and off. It's pretty cool for a little $5 device, and I don't remember how much I paid for this little LED board. Used to be able to get them for just $1 or $2 on AliExpress. Things have gone up in price a little. The shipping has gone up. So I'm glad I stocked up on a lot of things that I'm finally getting to play with a few years later. And these are this is a Pro model, but the regular models you can still get on Amazon for around, I don't know, $5 each if you buy 10 of them, or buy a few of them, or you can get an ESP82 or ESP32, which would do the same thing. Which I have one here that I haven't put together yet. These are about $8 on Amazon, $8 to $10, I think. They just have more pins. They're a little bit more powerful than the ESP8266s. Okay, this is the setup I just showed with the LED board, and I had the 3 wires. This is a DHT 22 temperature humidity sensor, and it's on a plug-in board, so I didn't need the wires. It's all made for this D1 mini board. So I'm going to show how easy it is to change sensors. I'm going to just pull these wires out, and I'm going to plug this in, paying attention that I get the pins lined up right. So there's TX in this corner and TX in this corner. And just plug that in. And now I have to go back to the software to make this work and reassign that one pin, which I will show. Okay, I'm back on the software. I just plugged in the DHT22. That's why I named it initially. So I took the LED wires out. Now I'm going to reconfigure that pin to work on the DHT22. So I go to Configuration, Configure Module, and D4 is the same pin that the DHT22 uses. And I have here, this is set up for the LED WS2812. I'm going to go on the list. There's drop down menu. DHT11. I'm looking for the DHT22, which is also known as AM2301. That's the actual chip. So I'm going to pick that, save it. It's going to restart the ESP, and hopefully all the data will show up if I did it right. There we go. You can see on the top here, there's the temperature, humidity. It calculates the dew point. So that's how easy it is to use these ESPs with this Tasmota firmware. All I had to do was reconfigure one pin. Now if I went back and changed that configuration again, if I went back here and changed this pin back to LED, it would, and plug those wires from the LED back in. I could also put the LEDs on in a different pin, and like choose the what I had here was the WS2812, so I could put it on like pin D2, and it should show both the temperature and the LED. So it's pretty cool. So you can assign all these pins to different functions, and you can see there's quite a range of options you have here. You can make these do all kinds of controls. Okay, when I was just editing the video, I noticed that my capture software wasn't showing the drop-down menus. So I'm going to show here, just using the camera, the old-fashioned way. What I was trying to show was, one of them I showed was here how you can pick different kind of boards. And we're just using the generic 18 pin for this board. But if you had different devices, you would choose these other options. And the other thing I was trying to show was these pin assignments. You can just go to, see, I clicked on the drop down menu and it gives all these different selections here. You can see there's a one wire DS1820, and there's all these other options. I'm trying to find the one I use, but it's hard to see through the camera, but you get the idea. You just choose
you have buttons and things. So you choose one of these and you can reassign it for a different function. Trying to find the one I used, but there's the this was the DHT 22 that I had earlier. Get the idea, and then just save it, and it would save it. So you could have more than one thing on one menu or on one device, because you have all these other pins to use. So you could do LEDs, and then you can also do, I haven't gotten into it, but you can write programs on this and have let's say you put a button on this, you can have it when you push this button, you can have it turn on the LED or change color or whatever. You can add some programming on here. So just thought I'd mention that since you couldn't see the drop down menus before.
Okay, one other device I didn't show that I've been playing with is this INA tester. Oh, I guess I can just click on this here and it'll open up the screen for it. Makes it easier than me typing it all in. So this is the tester. I'll show it in the video in just a minute, but let me turn on a load on this. Right now, I'll plug in a phone. See if it shows up here. I think one of my wires fell out. That's why it's not showing any load. I need to double check here, see which wire it is fell out. Green for ground. And I'm looking carefully to plug it in the right place. Here's ground. There we go. Now I'm getting some data in. 12 volts in. And 2 watts for this phone. So I'll unplug the phone. And I will plug in a lamp. Plug in an LED light here, just to show. There we go, 11 watts. And this is on my magnifying glass, so I can turn down the power level on the LED. And you can see it goes down. And change the, lets me change the different white light levels, like warm white, soft white, and it also changes the watts. So I'm going to show the device now in the video, the INA 219 tester. Okay, here's the ESP board I was just showing. This is another ESP8266, and it goes to this. I have 4 wires on this, which are connected up to this board here. This is the INA 219 voltage current testing board. I won't go through the wiring of that right now exactly, but it gets its data through these pins, and here's where the load goes through, and that's coming in. This is 12 volts coming in here, and then the output goes to this jack, which is going to, this is just a test setup. I have here a 12 volt to 5 volt USB adapter. So that's how I was testing that one LED light. But I can also set up a regular 12 volt load, which I will do. Okay, I plugged in this, get this to focus. Come on, focus. Doesn't want to focus. There it goes. I plugged this in. This is not on 110, it's 12 volts. I have a 12 volt light here, which says it's, I don't know if you can read that. It says 12 volts, 9 watts.
supposed to be 9 watts, 6500K color. I'm going to screw that in because we want to test that and see if it's really 9 watts like they claim. There, it's lit up. And we'll look at the screen here. It shows 15 watts, not 9 watts. 1 amp. So, you always got to test things. Anyway, that's coming through the same device here. This INA 219 is good for, I think, up to 26 volts and 3 amps. So not a lot of current, but good for testing things and being able to see it real quickly here. And of course, I could configure this to graph it all out if I wanted to. But it's the same way to set it up. Configuration, configure module. And this is an I2C device. So all I had to do was pick this on the 2 pins, SCL and SDA. And then Tasmota is smart enough to know that it was this 219 tester, and it filled all this in. That's why I love this software. You don't have to do too much. And it works great. I have the newest version in there. And you can see it's on the main, this Tasmo Admin. It's showing up here. Right here. Here's the IP address, the Wi-Fi signal strength, the version, how long it's been running, and the energy. Since I don't have anything on, let's turn this light bulb back on. Yeah, this one isn't showing up the energy on there, but it shows up on the main window. So, can't do everything on the, this is just an administrative program. Kind of lets you see all your devices at a glance and if they're working. But if you really want more detailed data, you go to the main screen here. Turn the light bulb back on. Turn it off. It's great. Handy.
Okay, I'm back on the Tasmo Admin, and you can see that I changed this right after I put the DHT 22 temperature sensor module in, and you can see it filled in the data over here, and it took the LED status out. And then also I don't have the toggle now to turn it on and off, whereas the other one supported the toggle. And I have some other devices on here. I have this Sonoff POW, and this shows all the data I have. This is a device that I reflashed that shows all the power data, and also will toggle on and off, so I can turn it on now. It turned on. I can turn on a load, like this waffle iron I just turned on, and it shows it's taking 1000 watts. Power factor's 1 because it's a purely resistive load. 8 amps. I'll turn it off. It'll add up all the power too. And then if I went on this Tasmo Admin screen, you can see I can also turn it on and off from here. Turn it back on, showing 0 watts. It shows the energy too on this. So I turn it back on, and it should fill in here. There it goes. Now you saw this jump up also. This is a different device. This is monitoring all my AC power. So we can go to that. I'll just copy and paste this one. No, that won't let me do it. Let's try it this way. I'll do it the easy way. I'll just change this to the address, which was 18. There it is. And now this is set up for MQTT data. Go to the console. It's showing all the data going out. And I have this set up so I can monitor it on a graphic, on a graph. Okay, this is the graph of that device, Sonoff POW, and I have it all the data, made a graph for it, and this part here shows, you can see it, 3 watts. I'll turn on the device, I'll turn on the waffle iron, and this one takes a little longer to update than the, just watching it here. Right here, showing 1400 watts. No, this is all the power. So this is actually this screen right here. Anyway, you can get it on the graph there. It updated. Inverter AC here. That's coming out of my inverter. I'll turn this load off. Takes a little bit for this graph to respond, but it's running on a Raspberry Pi. So I just wanted to show that if you take this device here and send the data out as MQTT, I've showed this on a different video how to configure this. You go here and configure this, and then when I went on the console, it's showing that it's sending the data out here to another program, which basically allows me to get it onto this program here and graph it. It's called Grafana.